So here we need to show that the following 4 points are the vertices of a parallelogram. Let us begin. We begin by considering a quadrilateral with vertices A, B, C, and D. Let the coordinates of the vertex A be 3, -2. Coordinates of vertex B, let it be 4, 0. Coordinates of vertex C, we're going to denote it by 6, -3, and the fourth vertex D has the coordinates 5, -5. Next, what we'll do, we will join the diagonals AC and BD. So what we'll do, we'll first obtain the coordinates of the midpoint of AC, and then we will find out the coordinates of midpoint of BD. So let us begin. So to find out the coordinates of midpoint of AC, first let's begin with the x coordinate. We'll sum up the x coordinate of the endpoints. So the endpoints are A and C. Summing up the x coordinates, that's going to be 3 plus 6, and we're going to divide it by 2. So that's going to be the x coordinate of the midpoint of AC. Then for the y coordinate, we take the sum of the y coordinates of the endpoints. So that's -2 and -3, and then divide it by 2. So this is giving us a value 9/2 and -5/2. Next, what we'll do, we'll try to find out the midpoint of the other diagonal, which is the midpoint of BD. Let's add up the coordinates of the endpoints. So those are 5 and 4. So we have 5 plus 4 divided by 2. And then to find out the y coordinate, we add up the y coordinate of the endpoint. So that's -5 and 0. And we divide it by 2. So that's going to give us 9/2, -5/2. Now what do we observe here? We observe that the midpoint of AC, let's say midpoint of AC is at E, has the coordinate 9/2, -5/2, and midpoint of BD also has the same coordinate. That means they are bisecting each other, and that is true for a parallelogram. So we can say that here AC bisects the diagonal BD. Now since AC bisects the diagonal BD, that means that ABCD must be a parallelogram. One may ask that what if it is a rhombus? To further show that it is indeed a parallelogram, so what we'll do, we will also show that the opposite sides are of equal length. So let's find out the length AB by using the distance formula. So we'll take the square root. Underneath the square root, what we need is the difference of the x coordinate. So we have 3 minus 4, so that's -1. We're going to square it. Then add it to the difference of the y coordinate. So that's -2 minus 0, so that's going to be -2. We're going to square that as well. And that's going to give us the length square root of 5. So here now we have obtained the length of AB. Now let's obtain the length of CD. So CD will be, so we'll take the square root. Underneath the square root, we need the difference of the x coordinate. So we'll take 5 minus 6, that's -1. We're going to square it and then add it to the difference of the y coordinates, so -5 minus of -3, so that's going to be -2 squared. Solving this also gives us the value square root of 5. So here we have shown that the parallel sides AB is equals to CD. Similarly, we find out the length BC. So BC will be, we'll take the square root. So BC here is 4 minus 6, so that's going to be -2. We square it, then add it to the difference of the y coordinate, 0 minus -3, so that's going to be +3 squared. So this is going to give us a value square root of 13. And then we find out the length AD. So AD is going to be, we take the square root. So underneath the square root, we have the difference of the x coordinate. So that's -2 squared. And then the difference of the y coordinate. So that's going to be +3 squared. So this is also giving us a length square root of 13. Now these two conditions are telling us that BC equals to AD. Hence we have now successfully showed that with the quadrilateral formed by ABCAD, the opposite sides are equal length and the two diagonals bisects each other. So that means ABCD is indeed a parallelogram.